We all know how to find the moon, but what if you wanted to go to Mars? Which way would you go? How do you find a moving planet in the vastness of space? Today, we'll freeze time and use orbital math to find Mars, but we'll go even deeper. We'll show you how to calculate Mars's speed using the Doppler effect, how to measure its distance using light, and even how to spot Mars from your own backyard. So watch until the end, because by the time we're done, you won't just know where Mars is. You'll know exactly how to find it. Earth rotates every 24 hours. That's what gives us day and night. It also orbits the sun every 365 days. That's 1 year. Our planet is always in motion, but we don't feel it. It just works. We live on a spaceship moving at 30 kilometers per second without even noticing. Now think about the moon. It's easy to find. It orbits Earth every 27.3 days. That's why we can track it. Full moon, crescent, eclipse. Totally predictable. Because it orbits us, we always know where to look. But Mars, that's another story. Mars doesn't orbit Earth. It orbits the sun just like we do, but it takes 687 Earth days to complete one full orbit. It also rotates. A Martian day, or sol, is 24 hours and 37 minutes. So here's the real challenge. If both Earth and Mars are always moving and on different orbital tracks, how do we figure out where Mars actually is and how to get there? Let's try something wild. What if we froze the entire solar system? No motion, just a snapshot in time. Let's say Earth has orbited the sun for 100 days. Mars has orbited the sun for 200 days. In this frozen moment, can we figure out where Mars is? Earth takes 365.25 days to orbit the sun. After 100 days, Earth has completed 27.4% of its orbit. Mars takes 687 days to orbit the sun. After 200 days, Mars has completed approximately 29.1% of its orbit. So in this frozen moment, Earth is at 99 degrees, Mars is at 105 degrees. They're just 6 degrees apart, but Mars is on a wider orbital path. In this moment, we could draw a straight line and say, there's Mars. That's the power of orbital geometry. You might think Earth and Mars move at a constant speed around the sun, but gravity has other plans. According to Kepler's second law, planets move faster when they're closer to the sun, perihelion, and slower when they're farther away, aphelion. Earth's average speed, 29.78 kilometers per second. Mars's average speed, 24.07 kilometers per second. But these are just averages. Each planet speeds up and slows down during its orbit. So when we launch to Mars, we're not aiming at a fixed point. We're chasing a moving, accelerating target. And timing is everything. So how do we know how fast Mars is moving? We use radio waves and the Doppler effect, the same principle that changes the pitch of a passing siren. From Earth, we send a signal at 10 gigahertz. If Mars is moving toward us, the radio waves are compressed, and we receive them at a higher frequency. Received frequency, 10.5 gigahertz. Doppler shift, plus 30 hertz, blue shift. And Mars is moving closer at approximately 0.9 kilometers per second. If Mars is moving away, the signal is stretched and we receive a lower frequency. Received frequency, 9 gigahertz. Doppler shift, minus 30 hertz. Red shift. Mars is moving away from us. And to measure distance, we use light time delay. How long it takes the signal to go to Mars and bounce back. Depending on orbital positions, this can take 10 to 40 minutes round trip. Even across 200 million kilometers, we stay locked onto Mars with math, light, and invisible waves. For thousands of years, Mars was just a red dot in the sky, a mysterious wanderer that moved differently from the stars. Ancient civilizations watched it with fear, fascination, and wonder. The Babylonians tracked its path. The Romans named it after their god of war. And today, we're sending robots to walk its surface. It's incredible to think We've gone from watching Mars to measuring, tracking, and reaching it. In reality, time doesn't pause. Mars is moving, Earth is spinning. The target never stops. That's why we don't aim where Mars is. We aim where Mars will be by the time we get there. This path is curved, not straight, and it's called a transfer orbit. Let's take a real example. NASA's Perseverance rover launched in July 2020. Scientists aimed not at Mars's current position, but where it would be 7 months later. That calculation led to a perfect landing in Jezero crater after a 480 million kilometer journey. That's precision, that's orbital math in action. So how do we always know where Mars is? Astronomers use orbital models to predict its location, days, months, even years ahead. We use NASA's solar system databases, planet tracking software, even mobile apps. Mars might be hundreds of millions of kilometers away, but it's never lost. It's just in motion, like everything else in space. Want to see Mars with your own eyes? It's usually visible as a reddish star, bright, steady, and unmistakable. Unlike stars, it doesn't twinkle. Use apps like Sky Guide, Stellarium, or Star Walk to track it in real time. And remember, the best time to see Mars is during opposition, when it's closest to Earth and fully illuminated by the sun. Look up, Mars might be watching you too. Here's something wild. Mars has blue sunsets. Unlike Earth, where the sky turns orange and red, Mars's thin, dusty atmosphere scatters blue light instead. At sunset, the sunlight travels through more atmosphere and dust. The red and yellow wavelengths pass through, but the blue light is scattered forward toward the observer. That's why on Mars, the sky around the setting sun glows soft blue, while the rest of the sky stays dark and reddish. Next time you look at the moon and think, there it is, remember this. Mars is out there too, orbiting, rotating, moving. And thanks to the beauty of physics, we know exactly how to find it. Now imagine this, what if we lived on Mars? A year would last 687 Earth days. You'd age slower, at least on the calendar. A day would be 24 hours and 37 minutes, almost the same, but with longer sunsets. And those sunsets? On Mars, they appear blue, not red. Life would be different. Thanks for watching and subscribe for more.